In this video, I'm going to go through the unit storyline for Unit B.1, developed by Open Syed. So you can see in the window below, I've created a document of big ideas. And this is useful when you're trying to think about, where in the unit are ideas introduced, key terms. Some people use it to figure out what big ideas they want to formatively assess throughout the unit. So go ahead and use that below if that's handy for you. But this is the unit storyline that's provided in the unit overview document. And I'm going to walk you through lesson by lesson and kind of give you a big understanding of what's in this unit. So first of all, I do want to point out that there's these icons, and the icons show you which routine of the storyline we are in. So lesson 1 is always the anchoring phenomenon routine, which means you will have some exploration of, in this case, it's going to be looking at the 30 by 30 initiative. We look at some data. We look at some examples of conservation that has happened across the United States. And actually, students are going to create in groups, initial models in groups this time. It's a little bit different than other units where their initial models, they look at some data and information about a conservation area and they create a poster about it. And it helps the conversation also talk about related phenomena, maybe other conservation efforts that they know of, as well as giving us a list of investigation ideas and how we can learn more about these conservation areas and what we can do to protect more areas. Now, I will say that some people are worried about the 30 by 30 initiative either going out of date or, maybe not anchoring the unit as well as it should. I would like to explain that the 30 by 30 initiative is going to come back in the end, and it kind of sets up a little bit of an engineering problem in a way, a problem-based unit in the fact that we need to preserve ocean and land. And so the best way to do that is to look at conservation efforts that have worked. And so we're actually going to look at the Serengeti in this unit as a really great example, which has been studied a lot to figure out some of the science ideas, and then how can we use that to help apply to other areas. So we will come back to these examples in the end of how do all the science ideas that we figured out help us evaluate these examples in the United States. So although the 30 by 30 is a very small part of the unit, it does set the stage to the fact that we need to have initiatives to help preserve lands. And the only way we can do this is by looking at what has worked. And so in 2030, if the 30 by 30 initiative didn't work, we need to figure out why, because we need to change that. Anyways, okay, so moving into, and there is a driving question board. I'll talk more about that in the lesson 1 video. And you will find that the questions are about habitats and animals, but also like, what can we do? Protection and policy. Okay, lesson 2, you're going to move into learning about the Serengeti, and we're going to have a scavenger hunt. We're going to look at different animals that are in the Serengeti, and then a map is provided or you need to print one out that's big or put it on I was going to say overhead projector, on a dot cam. And so put it under a dot cam, and then you're going to write some of the information they got from the data cards on that map. So that's represented here. Here is an example of the different maps. I think the migration route is introduced in lesson 2. Migration of the wildebeest is going to be a key phenomena in this unit that we're trying to figure out. What are the pressures that are creating this migration pattern? And so you can see the red is where that population of wildebeest is located at different times of the year. Okay, so we've been introduced to the Serengeti. And we watch videos and interviews of scientists and really understand how much this conservation plan in this area has been studied. Okay, lesson 3, we ask the question, why do the animals in the Serengeti migrate? And so we reflect on the migration patterns, and then we're going to get some data cards about the wildebeest. Here's kind of an example of one. It talks about some characteristics of the wildebeest and a part of their migration. And then we're going to summarize and record some of these ideas about predators and food on the map of the Serengeti as a class. Moving into lesson 4, we're going to talk about how is food driving the wildebeest migration. And so we watch an interview and we really think about rain, because rain is going to make the grass grow. And we thought that maybe food, we made some predictions and we thought that maybe food was going to be the biggest reason for this migration pattern. So if it rains a lot in certain areas, there's going to be more grass. So we would expect that the wildebeest would be in those areas during the high grass season, or the what they call the wet season. So we find out that the Serengeti has a wet and a dry season. But what we realize is that it doesn't exactly match the patterns of rain. The wildebeest go in a certain pattern, even though there may not be a lot of food there at certain times, or the rain doesn't totally match. There's not a direct relationship between the rain, and we really understand that food is a limiting factor. And so we are going to begin to really develop the idea that there are certain things in the environment that are going to limit the amount of animals that can be there. Okay. In lesson 5, we're going to talk about how food can affect population size. And I think most biology teachers know where we're going with this. It's going to be carrying capacity. And so we create a model. It's actually a kinesthetic model. You kind of act it out. Some teachers think it's silly, but I tell you, some teachers say the kids love it. And so they act out this kinesthetic model. Some people are wildebeest, some people, they're different parts of the ecosystem. And then we map the data and we can see that it goes up and down and up and down. And so what we realize is that an environment only can carry so many of the population of a species. And then when the food runs out, the population is going to go down because they starve. And so it goes up and down, very common concept in biology. In lesson 6, we're going to actually be at the end of our first lesson set. And this lesson set is going to assess all of those ideas we've developed into a new scenario. And that's what we call a transfer task, when they take the science ideas and they put it into a new context. And this context is all about that African wild dog right here. And so we will use our ideas about limiting factors and carrying capacity and apply it to the African wild dog in that transfer task. Okay, we're now going to begin lesson set 2. We want to know, how do all the living and non-living components interact in an ecosystem? So the next few lessons are all going to answer that question. It'll also answer those questions related to this on the driving question board. So we're talking about interactions now. So lesson 7, we are going to look at predator-prey interactions. And we look at the role of predators in migration. And we read about the behaviors of the wildebeest and their predators and how they relate to them. And then we play a game. So this game has been revised over the years. The newest version is easier than the other versions, just because the directions are a little bit more clear. So this one, I will tell you, you definitely need to go through, read the directions, kind of practice one round with your class, and then let them do the other rounds on their own. I will go deeper into this in lesson 7. But once they get it, and as long as you know the key ideas that students are supposed to get out of this game, it's easy to get there. But the game does take a little bit of time to play and a little bit of time to figure out how to play. But we look at the numbers and we develop this idea of algorithms, and it actually came up before with our other model of how mathematical relationships can be applied to population numbers. And so you can see a little bit of algorithms here. An if-then statement is really as deep as we go into algorithms. In lesson 8, we're going to use the SAGE modeler to start modeling, and you can see a kind of a picture of it right here, to model the interactions between components in an ecosystem. And there's a little bit of a mathematical model because you have to apply, like, if this happens, this is going to increase. If this happens, this is going to decrease. So there's some, it's not a lot of numbers or data that you can use, but you can see trends and patterns in the data. Well, if this population goes down, like if the grass goes down, the wildebeest is going to go down. And what we learn from this is that the wildebeest is a keystone species, that it has a ton of connections throughout the Serengeti. So we've developed that idea that if something happens to the wildebeest, it's going to affect a ton of things, and a ton of things actually affect the wildebeest. And what we conclude at the end is that the more species in an ecosystem, the higher the biodiversity, the more stable the ecosystem, even when there's a disturbance. So we go back and use that SAGE modeler, and we put in a few disturbances like fire, and then we see how that affects the ecosystem. And because there's such a high biodiversity, it remains pretty stable. Okay, that's the end of the science ideas. So you can see what we've developed as far as biology science ideas. What we're going to go into now are talking about conservation. There's a little bit of, I want to say, engineering ideas in here, because we're going to talk about interest holders and evaluating a conservation plan using goals or criteria. And so it's not really an engineering lesson set, but it does have a little bit of that flavor. So in lesson 9, we're going to talk about, the main question is, how do humans interact with the Serengeti system? And so we are introduced to interest holders. We look at what they want to happen, and we actually look at a proposed road that's going to go through the Serengeti, and different interest holders want different roads for different reasons, of course. And that sometimes what's good for one interest holder is not good for another, but really what's important is the effect on the ecosystem. So we kind of evaluate this road proposal, and then we return in lesson 10 to our original conservation examples. Some are in the Everglades, some are in Arizona with the cactus, and we evaluate if the conservation effort is working. So we look at a focal species in that example, and we do an evaluation using all the ideas we have figured out. Looks like I forget. I think we do a comic strip in that one. And then in lesson 11, we are done. We are now going to have our final end of unit transfer task. And so we are going to apply everything, science ideas and this little bit of conservation engineering evaluation ideas, into a new context, which is the American Prairie Reserve. So this is a really cool unit, especially if you like ecosystems and the Serengeti. If you know anyone who's been to the Serengeti, get some pictures, have them come in, talk about it. It's pretty amazing to talk about. All right, let's get into lesson 1.